we're starting the first section in the review chapter of prerequisites, and we are starting with section number 1. These sections in the book are very long because they cover most of everything that you would have discussed in Algebra 2 / college algebra. So I'm going to break it down into pieces to make it a little bit easier so that we can keep the videos to a shorter length, and then hopefully find it a little bit more interesting and don't get bogged down with too much information all at one time. Alright, the very first thing, as you can see that's up on the board, is the set of numbers that we have come to know and love. The natural numbers, that was the first set of numbers that we learned, the counting numbers, 1, 2, 3, 4, as indicated. Notice the symbol, it looks like a capital N with an extra line slashed through it. The whole numbers, that's the same thing as the natural numbers, except it also includes 0. The set of integers, that's all of your whole numbers and all of their opposites. Of course, the opposite of 0 is 0. And notice that the integers, it looks kind of like a capital Z with an extra slash through it. Then you have the rational numbers, everybody's favorite, fractions. Rational numbers are any numbers that can be written as a fraction. Notice the notation here, P over Q, such that P and Q are elements of the set of integers and Q is not equal to 0. Because we know that we cannot divide by 0. That's why we have that stipulation there. The rational numbers, you'd think it'd be a capital R, but they're saving that one up for the real numbers. It's a capital Q with an extra slash through it. Now, to be honest with you, I haven't seen very many notations for the irrational numbers, and the irrational numbers are all those numbers that cannot be written as a fraction. One of our favorites, of course, is pi, or perhaps you like the square root of 5. Those are numbers that when you write them in decimal form are non-terminating and non-repeating. Now, the textbook uses this kind of weird-looking capital H here with the extra slash through it. As I mentioned, I've not seen that one before. Now, the set of real numbers, which for right now, that's all we're going to be dealing with for quite some time, are the real numbers. That's a capital R with an extra slash through it. And those are all the numbers. Those are all your rational and your irrational numbers combined. Now, I also wanted to make mention of some notation here. This symbol here is a little bit like, it looks a little bit like less than or equal to, but that's a U shape it's on its side, and that means this is a subset of. This, of course, is still equality, which means any set can be a subset of itself. And what it means to be a subset is that every element in here is contained in here. And what I have written down is the set of natural numbers is a subset of the set of whole numbers. And as you can see, all the natural numbers are contained in all the whole numbers. I also have the notation for something you probably remember, and that's the empty set symbol. Of course, the empty set technically is a subset of any set, and you can either use the empty braces like this, or you could use this, the 0 with the slash there like that to represent the empty set. And we're going to break this down a little bit more when we start talking about inequalities and notation, but that's for the next one. So I need a new screen here, so let me just back up and see if I can. Oh, here, that's much better. Now, the inequality signs, which you guys should be familiar with, less than, greater than, less than or equal to, greater than or equal to, are used for order. You know, what is bigger than what? Now, the does not equal to symbol, which is an equality sign with a slash through it, is technically an inequality sign, but for the most part, we'll use that for exceptions and restrictions rather than solutions to statements and such. I have an example. X is greater than or equal to 3, and I've drawn out a number line. Now, I went ahead and I put down a whole bunch of numbers. You don't need to put down that many, just as long as the key value here, which is 3, is represented. And in Algebra 1 and in Algebra 2, most likely in college algebra, probably not in college algebra quite as much, you were asked to represent this on a number line using filled in dots and empty dots. The equality means you want to include the 3, so normally if we just have the point 3, we put a circle right there, fill it in at the number 3, but we also want to represent those values that are greater than 3. And there are lots of numbers greater than 3, can't list them all, but we can represent them by shading in to the right here, and then putting an arrow down like that to indicate that it's from 3 on up. X is greater than or equal to 3. The example below, all real numbers between 5 and 8 inclusive. Well, because it says inclusive, we want to include the 5. Notice my key values are kind of in the middle here. we want to include the 5, we want to include the 8, we want all the numbers in between, which would look like this. Now to represent that with an inequality statement, we would write that 5 is less than or equal to whatever variable we choose to use. We can use x. Is less than or equal to 8. Notice that it's in the same arrangements as the numbers on the number line. Makes it a little bit easier. Now, this is kind of the old-fashioned way of doing set notation or interval notation. We are going to use the new version of interval notation, which has become really popular in the last 15-20 years. And I'm going to go ahead and represent that same two sets up there. So for x greater than or equal to 3, to represent, we want the 3 and we want everything bigger than 3. We don't use a filled-in circle or an empty circle. We use either a parenthesis or a bracket. And because I'm shading to the right, I'm going to have my parenthesis or my bracket open to the right. And because I want the equality, I'm going to use the bracket. The bracket's kind of like the filled-in circle. So I'm going to put a bracket right here on 3, and then I'm going to shade to the right. And you say, well, that's not much different than the filled-in circle. Well, that comes with the idea that we don't have to write our statement out here in a more traditional set builder notation, but we can write it out with a bracket, the 3, it goes on forever, so comma, and we use the infinity symbol to represent that it goes on forever. We don't put a bracket next to the infinity symbol because that would indicate that it stops somewhere, and infinity goes on and on and on forever. So this is interval notation. It's what you need to get used to if you're not already used to. This, I'm going to try to show you examples, and then pretty much I'm going to use this all the time throughout this class. Now down here, notice that we have filled in circles here, so those are going to be brackets. We want everything in between. On this side, it's to the right. On this side, it's to the left. So I'm going to put a bracket here at 5, a bracket going the other direction at 8, and shade in between. And of course, the interval notation here would be just what the number line looks like. It looks like 5, comma 8, with brackets on both sides. Now, in the example below that, I've already written it, represented a graph there on the number line, a set of values, and I'm going to write it in set builder notation, what we're kind of used to seeing, and also in interval notation. So in set builder notation, well, I'm going to get really fancy here. I'm going to write the set of all x, pick any variable you choose, such that, and in this case, these are numbers smaller than 4, not equal to 4. Notice it's a parenthesis, so it's like the open circle. So what I'm going to do is I'm going to write x is less than 4. Now, not every textbook does this, but I had to do this when I was in school. I would have to put a comma, and I would have to say that x was an element of the set of real numbers. It's kind of old-fashioned, and it's a lot to write out. You can see the advantage here for interval notation. I'm going to have all the numbers from 4 smaller, and notice the parenthesis opening up like this. So here's the 4 with the parenthesis, means not including that, and I want everything smaller to negative infinity. So to the left, I put the negative infinity symbol, and of course a parenthesis next to that as well, because it doesn't stop. It goes on forever and ever. Okay, we have one last example here. Oh, I felt like the building shook for a second. It says, give the interval from 1/2 to infinity, graph the set number line, and write the set builder notation. Now notice here, just like we were talking before, a bracket means that we're going to include this, so it'd be like a filled-in circle in the old notation. We don't even have 1/2 here, so I'll mark 1/2 right here, which of course between 0 and 1, and I'm going to have a bracket and then everything to the right because its value is going to infinity, bigger. And arrow on there to indicate that it goes on forever and ever. Now, the set builder notation, that's the way I was taught. It's a little old-fashioned. I like the interval notation better, but I'll go ahead and show you that it will be, I'm just bringing it up here because I'm running out of space. It would be the set, brace, of all values x, such that you can use any variable you want, again, and x is greater than or equal, because of the bracket there, 1/2. And of course, x is an element of the real numbers. Okay, I hope that helps a lot, and we'll go on to the next topic.